All right, so let's start to go through the last three and finish off our functional groups. So we're going to start off with esters and basically go through the same thing that we went through over the last little bit, where we talk a little bit about some of the properties and then start to look at these IUPAC naming structures as to what they are. So esters, they're known for their pleasant aromas. So they give blueberries and pineapples, for instance, their characteristic smells. Esters contain a carbonyl group again, but this time it's linked with an oxygen and then it carries on with a carbon chain. So we have this double bonded oxygen, which is our carbonyl group to the carbon, but then we have another oxygen followed by a carbon chain. So there's two oxygens in this one. One's double bonded to a carbon, that's the carbonyl group, and then the other one kind of starts another branch. So it has an oxygen and then starting off another branch after that. Okay, so esters can be prepared from carboxylic acids and alcohols, and the reaction is reversible, so we can go one way or back the other way. So if we take a carboxylic acid, which is what we discussed in the last section, and react it with an alcohol, have a hydrogen ion as a catalyst, then we can make an ester that gives us a double bonded oxygen, and you can see here there's our double bonded oxygen. It's taking the hydrogen from it and giving water as a product, and so we can actually make our ester from carboxylic acids with alcohol. So some of the principles with it in naming esters: we're going to remove the E ending and we're going to replace it with OATE or O8. The parent chain is then attached to the carbonyl compound, and the branch is attached to the alcohol grouplets there. So, parent chain attached to the carbonyl compound, right here. The branch chain attached to the alcohol that follows. So in this case, I'd like for you to pause for a second, see if you can figure out what these are, and then we'll come back and go over them. Alright, so we've got this double bonded oxygen making our carbonyl group. Now we have 1, 2, 3 coming off of here. So looks like our parent chain coming off our carbonyl group is going to give us propane. But then we need to remember our endings, right? Propanoate. And then in front of that we have our methyl group, because our branch chain gets attached to the alcohol that's there. So next one, same thing, but notice this time these are flipped, right? The oxygen was on the right here, the alcohol part, where the alcohol part is on the left in this one. So here, hopefully you kind of realize that part, and then we had our chain going on the right over here, which means that we have ethane or ethanoate. And then on the left, 1, 2, 3, 4, 5, we've got pentyl ethanoate. So whatever's attached to the carbonyl group, there's your parent chain, and whatever's attached to the alcohol becomes your branch. So again, pause the video, try to draw this out. So butyl hexanoate. See if you can draw that out and then come back when you're ready. Alright, so hexanoate, it's our parent chain, so 6 carbons off the carbonyl compound. Butyl gives us our branch off of the alcohol compound. So 1, 2, 3, 4 off of the alcohol compound, off the oxygen. Double bonded oxygen to this carbon, there's our carbonyl group. 1, 2, 3, 4, 5, and 6 for our hexanoate. So moving on, next functional group we're going to go through is amines. So when naming amines, the compound structure has at least one carbon chain that gets attached to the nitrogen. So as we start to look through the different groups that are here, what you'll see here is that we have a nitrogen group that has a lone pair attached to it, and I guess one of the things that we need to recall from previous knowledge when we go through the octet rule and things with lone pairs and all that kind of stuff, is that nitrogen has 5 valence electrons in it. But even though it has 5 valence electrons, it cannot form 5 bonds because 2 of those electrons make a lone pair. So nitrogen can only make 3 bonds. So nitrogen in this case would make, say, 3 bonds with the hydrogen here, which would be ammonia, and that's not an amine. That's just a regular compound. Then I've got nitrogen that's here, and then this nitrogen has a carbon chain coming off it. We call that a first degree amine. It's got 2 hydrogens that are here. So you see that one with the circle in it, first degree. Second degree amines, nitrogen with 2 carbon chains coming off of it, and then third degree amines, all 3 carbon chains coming off that nitrogen. Because this is an intro course to functional groups and organic chemistry in general, we're really going to only look at those first degree amines. And just to let you know, again, characteristics, they're found in things like morphine, Demerol, pain relievers, as well as things like anesthetics and dyes. So just to give you kind of an idea of what an amine is. Amines also have kind of their root word is actually buried in something that you would actually know kind of on your day-to-day life. Vital amines were coined a little while ago by some scientists that were kind of studying different compounds that the body needed to survive. And those vital amines, if you were to break that word up, actually kind of breaks down into our current use of the word vitamin. And so if you take a look at the word vitamin and vital amines, you'll see a pretty good connection in there. So amines are actually pretty important just in terms of our day-to-day living and what our body needs to survive as well. And not all vitamins are amine groups, but how it started was basically with this understanding of these vital amines because of what was being observed by these scientists at the time. So to name them, we drop the E off the end like every other one, and in this time we just add in amine. So all previous naming structures can apply. So in this case, we've got our first degree amine that's there. We've got this NH2 coming off of it, and so we can see we've got 2, because it's happening at the second carbon, propane, amine. So just out of curiosity, I'd like to see what you think this one might be. I've got my NH2, and then my chain would be here. And we've got no double bonds here, so it's not a benzene ring, right? Cyclohexane-amine. So really it'd be cyclohexane, and again we drop the E right in amine. Next one, what would be the structure for 4-methyl-2-pentanamine? And take a second, try it out, see if you can build it, and then come back when you're ready. Okay, so pentanamine gives us 5. It's saying at 4 we have a methyl group coming off of it, and 2 is where this amine structure, this nitrogen, is going to be. So at 2 we have our nitrogen structure, and then if we keep counting over at 4 we have our methyl group. So you can kind of see how these things can start to be built and be a little bit more complex. And our last ones, amides. So amides have a carbonyl group attached to the compound structure, in which case they take the shape of this double bonded oxygen to the carbon, and then they have an NH2 coming off of them. So before it was just a carbon compound that would connect to our amine group, but amides have this carbonyl structure also attached to them. Okay, so a little bit more complex. They can be used to form resilient structural material like nylon and Kevlar, and the naming system is just similar to that of amines. So there's also first degree, second degree, and third degree amides, but again, it's an intro course. We're just going to take a look at those first degree ones. So a couple of examples that are here, following the same kind of rules, ending in amide, the same as amine. So you can see here we've got our double bond. It's ethane because there's 2 carbons, and so get rid of the E, add in amide, and we have our name. So 3, propanamide, and I'd like for you to think about these ones for a second, see if you can come up with the names for them, and unpause when you're ready. Alright, so this one actually has a halocarbon group attached to it, but again, we're starting here with our carbon group that's attached to our amide. So if we remember from before, it's not bromine because it's on a branch, so we have 2 where it's happening at, bromo, and then 1, 2, 3, 4 carbons, butane, amide. Next one, double bonded right here, going down into this one, okay, and this one has kind of its own little name because it's a benzene ring, so it's benzene amide. It has this amide structure coming off of it, off of the benzene ring. So, the last 3, going through what we just covered, okay, going back through, we've got esters, amines, and amides. So, there's a worksheet that's ready. It's the last worksheet that's basically before the unit test. That would be on all of the stuff so far. So once you're ready, you can either print off the worksheet off the website or come on over and grab one. And if you have any questions, please let me know.